This is the Constant Velocity Motion Lab, Ethan O'Brien, Lab M04, and I took a video of a tennis ball being rolled across the table, and I'd like to show how there's zero net force and how my model predicts the outcome. Here you can see the tracker software where my friend rolls the ball across the table, and you can see the vectors following it across, and this shows the velocity of the ball. In order to predict my model, I used this software, and I was able to find that the mass of a tennis ball is 0.06 kilograms, and from this I was able to find the velocity, which is the delta x divided by delta t,
which is the final position minus the initial position divided by the final time minus the initial time. I set the velocity to 1.2 seconds, and I applied Newton's second law, which is velocity final equals velocity initial times force net divided by mass, which is all multiplied by the change in t. Now I run the software, and it will show that the ball is in the positive direction, and it keeps on moving in the positive x and y. This is the plot of the data. X is the m, or t of x. What if I chose x going to the left? And this is a demonstration of what would happen. And you can see that is the same as x going to the right, except that the ball is moving to the left and is in a graph. Another question is, what if the origin is different? Here you can see that I change it to 2, 2, 0, and you can see how the graph shows that the origin is slightly above it. Make it more clear by showing 5, 5, 0, and you can see that the graph starts much higher. So what we found was that we start with V constant, and it shows that the total pushes and pulls equals 0, which is F net, and if F net is not 0, then velocity is not constant, and we can demonstrate this by making F net different variables. As you can see, it moves up and changes direction and speed.